Example 4. Find all asymptotes of the function r of x equals 3x to the fourth plus 4 over x cubed plus 3x. So let's first look for vertical asymptotes. Remember, to look for vertical asymptotes, we must factor the numerator and denominator of the function and reduce it to lowest terms. So if we look at the numerator, if there's nothing to factor out, the numerator will not factor. In the denominator, we can factor out an x, and then we'll be left with x squared plus 3. So our function is in lowest terms, so if we set the denominator to 0, we'll find any values to exclude from the domain, which would be, in this case, location of vertical asymptotes. So if we set, for our VA here, we set x times x squared plus 3 equal to 0, so that either means x is 0, so we have a vertical asymptote at x equals 0, or x squared plus 3 is 0, but you can see if we try to solve that, there's nothing we could square to give us negative 3, no real number. So you know that if you tried to take the square root of both sides, you get plus or minus I radical 3. And we can't have imaginary asymptotes, so there's no real number that would cause this to equal 0. So our only vertical asymptote is going to be x equals 0. Now we have to determine whether we have horizontal or oblique or neither. So remember, we'll have one or the other or neither. So to do that, we want to compare the degree of the numerator and the degree of the denominator. So we can see the degree of the denominator here is exactly 1 less than the degree of the numerator. So this is degree 3, this is degree 4. It's exactly 1 degree less. So we know we're going to have an oblique asymptote. I'll abbreviate OA. So in order to find it, remember, we have to perform long division. So we have our x cubed, and you can put a placeholder if you'd like in here for x squared plus 3x. And if you want to put in a 0 there for that placeholder for the constant, you don't have to. And we're going to divide into 3x to the fourth plus 4. Again, if you want the placeholders, you can put them in here. So we're going to divide 3x to the fourth by x cubed. We'll get 3x. We'll multiply down 3x times x cubed, 3x to the fourth. 3x times all those zeros, so this will be 0x cubed. Then we have 3x times 3x, which will give us 9x squared. And then we've got 3x times 0 again, so we've got 0x. We want to subtract. And if we want to distribute that negative to all these terms so we don't forget, subtract the 3x to the fourth, and you get 0. These are just zeros anyway. And then we want 0x squared plus negative 9x squared, so that gives us negative 9x squared. And if we want to bring down our 0x plus 4, we can see now x cubed will not go into negative 9x squared, so we're done, and we don't care anything about the remainder. We don't care about anything down here. All we care about is the quotient. So our oblique asymptote will be at y equals 3x. So our oblique asymptote, y equals 3x. Now just to give us a visual of this on the graph, so I've entered the graph of my function, 3x to the fourth plus 4 over x cubed plus 3x. Remember, we always want to put parentheses around the entire numerator divided by the entire denominator also in parentheses. If you leave out the parentheses, it will be the incorrect function. We've got to group the numerator and group the denominator. Now, I also have graphed here the oblique asymptote y equals 3x. So I'm just graphing on a standard viewing window, zoom 6. Now there's the graph of our function, 3x to the fourth plus 4 over x cubed plus 3x. And there's that line, that boundary line, that oblique asymptote. So you can see those boomerang-looking shapes, those ramp-looking shapes, those branches that fit within the asymptote. So we can see we've got a vertical asymptote. You can see the vertical split at x equals 0. Now, when we're zoomed in like this, it kind of looks like that oblique asymptote slices through, which it does there, close to the origin. But if we zoom out, now I'm way out, away from the origin. There's our graph. You can't see those boomerang ramp shapes anymore, and there's that y equals 3x. So that's the definition of an oblique asymptote. As the x gets really large to the right, away from the origin, and really small, away from the origin left, that graph approaches the line y equals 3x. And if you zoom out, it actually looks just like a y equals 3x graph.